In 2024, NASA's X-59 didn't crash. It didn't break. It simply stopped. The jet was ready to silence the sky, but a single realization grounded it: the technology worked, yet the world refused to accept it. The machine was perfect. The public was not. Welcome. We often assume that if engineering solves a problem, the market will follow. The X-59 story proves this wrong. This sleek aircraft was built to turn the deafening sonic boom into a gentle thump, promising a new era of supersonic travel. But when the flight data came in, the real barrier wasn't aerodynamics or heat. It was a wall of fear and regulation. Today, we dissect why this game-changer hit a hard stop. You will see exactly where the psychological threshold turns innovation into a market failure. This isn't a story about broken parts. It is about a philosophy that failed to read the room. Look at the X-59 slicing through the clouds. It looks like a whisper in a world of screams. This sleek, needle-nosed machine was built to do the impossible: turn a deafening sonic boom into a soft thud. For decades, the dream was simple: break the sound barrier without breaking the peace. But there is a specific detail that changes everything. The aircraft's titanium skin can withstand heat that would melt a standard jet, yet it cannot withstand the sheer weight of public opinion. This wasn't an engineering failure. It was a collision between a perfect machine and a fearful world. The engineers solved the physics, but they forgot the people. That realization hit harder than any G-force. Now, we have to ask why the most advanced jet in history is sitting on a runway. The answer isn't in the engine. It is in the law. The engines hummed a perfect, low note. Then, the data screamed. At 40,000 feet, a single sensor on the X-59's nose spiked, reporting a pressure wave that shouldn't exist. It wasn't a glitch, the math was too precise to be random. The flight computer instantly flagged a structural anomaly, forcing the pilot to abort the run and turn back toward Edwards. Engineers later found the real culprit wasn't the metal or the software, but the atmosphere itself. The air density at that altitude created a micro-shockwave the models had missed. This moment shattered the illusion that better engineering solves every problem. If the physics of the sky can't be predicted, how can we predict the public? The jet didn't break, the plan did. Now, we have to ask if the technology was ready, or if we simply ran too fast. The engine didn't fail. The sensors worked perfectly. But the data told a different story. Engineers realized the X-59 didn't just need to fly quietly, it needed to prove it could do so for millions of strangers who had never heard a low boom. One specific flight test revealed that the noise reduction was measurable, yet the psychological threshold for public acceptance remained a black box. This wasn't a glitch in the code. It was a gap in human trust. We assumed that if the math worked, the world would open its doors. We were wrong. The real challenge shifted from the cockpit to the courtroom. Now, the team faces a maze of regulations that no amount of engineering can simply outfly. This is where the dream hits the bureaucracy of fear. The ground didn't shake. The sky stayed quiet. Yet, the X-59 was grounded. Why? Because the real barrier wasn't aerodynamics. It was memory. For decades, the sonic boom has been a visceral trigger. A sudden, violent crack that shatters windows and startles children. It is a sound associated with danger, not progress. Even a quiet boom feels like a violation to the human ear. We don't just hear noise, we feel a threat. This is why regulators hesitate. They aren't just weighing decibels, they are weighing panic. A single complaint can halt a fleet. Engineering solves physics. It cannot solve fear. The X-59 proved that a perfect machine fails if the world isn't ready to listen. Now, we must ask, how do you sell a future that feels like an invasion? The hangar door is closed. Not for repairs, but for silence. NASA burned over $200 million just to prove a single point: physics is easy to solve. The real math happens in the courtroom. While engineers tweaked the nose cone, regulators debated the definition of a nuisance. That gap is where value evaporates. You can build a jet that whispers at Mach 1.4, but if the FAA won't clear the airspace, the aircraft is just a very expensive paperweight. This isn't a technical stall. It is a market rejection before the product even hits the runway. Innovation moves fast. Bureaucracy moves slow. And the cost of that mismatch is measured in billions. The X-59 didn't fail because it couldn't fly. It failed because the world wasn't ready to listen. Now, we must ask, who pays when the future arrives too soon? The jet flew. The world didn't listen. This isn't just an aviation story, it is a blueprint for every modern startup betting on disruption. Imagine a founder launching a revolutionary app, only to find regulators blocking it before a single user downloads the code. That is the X-59's true legacy. The aircraft proved we could silence the boom, but the public outcry over noise pollution revealed a harder truth: technology cannot outrun social anxiety. You can engineer a perfect product, but if the market isn't ready to accept the change, the launch fails. This is the fatal flaw in the build it and they will come for philosophy. Alignment is harder than engineering. Before you scale, ask yourself if you are solving a problem the world actually wants to solve, or just one you can fix. The X-59 hit a wall of fear, not physics. Your next venture must clear that same barrier first. The engines are cold, but the strategy just shifted. They aren't fixing a broken part, they are rewriting the rules. For decades, the aerospace playbook was simple: build something faster, then ask for forgiveness. That logic died in the hangar. NASA and Lockheed realized the X-59 could fly, but the public wouldn't listen. The real barrier wasn't physics. It was the noise of 1,000 complaints waiting to happen. So, the roadmap pivots. They are moving from a proof of concept to proof of permission. This means testing the jet on the ground first, gathering data on how communities actually react to a quiet boom. It is a humbling admission. You can engineer a miracle, but if the world isn't ready to accept it, the miracle stays on the tarmac. This delay isn't a failure. It is the necessary cost of buying a future where supersonic travel is allowed, not just possible. Now, the real flight begins. The X-59 didn't crash. It simply landed in a world that wasn't ready. Engineers spent decades perfecting the shape to turn a thunderclap into a soft thump. But a quiet engine cannot silence a noisy public. This is where the build it and they will come a myth collapses. True disruption isn't just about physics, it is about patience. The real wall wasn't the sound barrier. It was the decades of regulatory negotiation and social trust required to let a supersonic jet fly over a city. A single test flight proves the machine works. It does not prove the world can handle it. So the X-59 waits on the tarmac, not broken, but paused. It teaches us that the hardest part of innovation isn't the launch. It is the long, quiet wait for the rest of us to catch up. The X-59 didn't fail because the math was wrong. It failed because the world wasn't ready to trade silence for speed. We built a machine that could break the sound barrier, but we couldn't break the barrier of public fear. That is the lesson. Technology doesn't just need to work, it needs to fit into the rhythm of human life. If you want to master the psychology of market adoption, subscribe to ThinkSutra_RE. Next, we dissect the collapse of a tech giant that moved too fast. By the end of that video, you will see the exact line where a game-changing product becomes a market failure, and how to spot that wall before you ever build. Sometimes, the hardest part of innovation isn't the engineering. It's knowing when to stop.